The ephemeral and almost otherworldly phenomenon known as the aurora has long inspired our curiosity. It is unlike anything else we can witness on Earth. Only recently, really within the last 150 years, have we been able to begin to understand its physics and implications. The science and enjoyment of the aurora reminds us how much we've learned about this type of space weather and also how much remains to be discovered. Hi, everyone. Mike Fitz with explore.org here, the world's largest live nature cam network. To explore the aurora, I'm joined by Alan Dyer. He is a contributor to Sky News as well as Sky and Telescope. He's also the co-author of The Backyard Astronomer's Guide and leads aurora watching trips to the Churchill Northern Study Center in Manitoba, where our Northern Lights cam is located. And Alan, I'm glad that you're here today. Thanks so much for taking the time.
Oh, my pleasure, Mike. It's always great to talk about the Northern Lights. It is one of my favorite sky sites and draws people from around the world to Churchill to see it.
It is utterly stunning, even when you see it on the webcam. And I know that I have a bunch of questions, of course, for you to pick your brain about the aurora, but our audience probably has questions as well. So throughout the chat today, if you're watching at home and or wherever you happen to be and you have questions for Alan, drop those in the comments. I'll try to get Alan to answer at least a few of those towards the end of the broadcast. So thanks for submitting those questions in advance. And Alan, I wanted to kind of set up the basics of the aurora because it's such a strange phenomenon. It's not like clouds or something that we can sort of physically feel or understand. I mean, a lot of us have felt fog, and clouds and cold winds, so we can kind of understand the weather patterns as we physically feel them. But we can't physically feel the aurora. We can just kind of visualize it itself. So to try to understand the basics of it, can you start maybe at the beginning and talk about how the aurora is related to the sun?
Well, the Northern Lights, the aurora, or aurora australis, there's the Southern Lights as well, occurs very high up in our atmosphere. Starts at about 80 kilometers and goes up to about 500 kilometers. So it's a very difficult part of the Earth or the atmosphere to reach. It's below where orbiting satellites fly, although the space station can fly through the tops of the aurora curtains. And it's too high for rockets or balloons or for aircraft or balloons. And so the only way to reach up and actually touch the aurora, as you say, is with rockets, sounding rockets that go up a few hundred kilometers and then come back down again. They don't go into orbit. And so it's a very difficult phenomena to study, but you can see it easily just by looking up when you're at a location like Churchill. And it just dances in beautiful colors and beautiful motions. It occurs because of the sun, essentially, is the source where the aurora cause and effect starts. And that was something that was really only discovered and realized 100 years ago or so in the early 20th century. Everybody knew the sun gives us light and heat, but it wasn't until well into the 20th century where we begin to realize the sun can send us stuff, can send us matter, electrons and protons. First of all, of course, we didn't even discover electrons until the 1900 or something like that. And then scientists realized that these particles can blow out from the sun in a constantly blowing solar wind. And that solar wind of particles from the sun, and they're charged particles, they have electric charges, and they are attracted by magnetic fields. The Earth has this global magnetic field that originates inside the Earth. And those magnetic field lines stretch out around the Earth. And particles from the sun are attracted by magnetic fields, and they enter that magnetic field domain around the Earth, or they interact with the particles that are already there, and they impart extra energy to the electrons and protons that are already in the Earth's magnetic field, and they give them more energy. And those particles are then wanting to try to get back to where the magnetic field lines originate inside the Earth. And they're stopped by our atmosphere. And so these particles rain down around the north and the south magnetic poles of the Earth, causing a ring of light around the north and south geomagnetic poles. So there's a southern lights and also a northern lights as well. But the southern lights are not as easy to see because they're mostly water and ocean underneath the region of the southern lights. But the northern lights are visible in that oval around the world. Northern Canada has the greatest geographic extent underneath the aurora. Southern Greenland, Iceland, northern Scandinavia, and the northern tip of Russia as well. But again, it's Scandinavia, Iceland, and Canada, and Alaska in the US that are the prime destinations to get to where the aurora occurs most often. And if it's clear, chances are you're going to see some display of northern lights if you're in that location underneath the prime auroral oval.
And the aurora takes many forms when it manifests itself in the atmosphere. My next question for you is actually a question, the first viewer question that came in. Somebody was wondering what makes the colors of the aurora change. When you watch the aurora, it's often green, but not exclusively green. And there's a lot of different forms that it takes. So what causes it to change?
Well, the colors, first of all, it is green is the primary color that you see. It's the first color that you're going to see with the eye. The camera picks it up really easily. That's from oxygen. And so the Earth's atmosphere is primarily oxygen and nitrogen, but way up high where the aurora is occurring, it's oxygen that's more prevalent than the nitrogen. And the incoming charged electrons interact with the oxygen atoms and molecules and excite those molecules into glowing colors. Green primarily, but there's also a red color from oxygen, which typically occurs very high up at the tops of the auroral curtains, like we see here in the picture. And the cameras pick up the reds very, very easily. Your eye has a tough time seeing those oxygen reds, but when aurora gets very bright, that can be visible as well to the eye, but the camera picks up. And here's a great shot from the space station, in fact, looking over Alberta in Western Canada, showing you the red at the tops of the auroral curtains, and then down further is the green, and that's more of the common forms. And they form these rays or streamers because the particles are following along the magnetic field lines. It's like the old high school science experiment or grade school science experiment where you put the paper, you sprinkle iron filings on a piece of paper and there's a magnet underneath it. And those iron filings form this pattern along the magnetic field lines. And so that's the basic idea of how you get the shapes. It's generally, the auroras are generally curtains, and quite thin curtains, and often several of them in parallel. And the particles are raining down those curtains and then stopping at around 80 kilometers or so. That's where the air now gets too dense for that excitation of the oxygen and nitrogen molecules to even happen. So the aurora doesn't go down below about 80 kilometers. But at the very bottom of the curtains, you can occasionally get a pink fringe, and we kind of look for that. That's a sign that the aurora is getting really active and more excited. And that pink fringe is from nitrogen. And so that reaction only occurs in that very bottom edge of the auroral curtains. So we don't often see it, but when we do, you can see it with the eye, and it looks really great. And these videos here do show you pretty well what you see. This is real-time video, and that's what you do see with your eye. And when it gets bright, you see the greens and you see the pinks with your eye, not just by the camera.
You also mentioned that it's really just a fairly recent scientific phenomenon or understanding that's taken place to help us, just begin to understand the aurora. But there's still a lot to learn. And I want to take a few moments to ask you some questions about what we don't know or what has been discovered recently. For example, there's a relatively new phenomenon, or not maybe a new phenomenon, but one that's recently described associated with the aurora. It's the acronym is STEVE, and that stands for Strong thermal emission velocity enhancement. And that was described just a few years ago. So what is this, and what makes Steve different from other more typical auroras?
Yeah, Steve is a great story. Steve was kind of discovered, as it were, by colleagues of mine here in southern Alberta. Actually, first identified over beers at a local pub after a seminar at the University of Calgary, and some of the amateur astronomers, were saying, "Oh, I took some pictures of what was being called at the time a proton arc." And the Aurora researchers there said, no, that's not a proton arc. That's a different phenomena. That's something different at all. But what is that you're seeing? At this kind of pink band across the sky. And we had photographed it, for several years before that. And it had been observed, this anomalous arc across the sky, which is always south of the main auroral band. So we typically in Western Canada here, we might see the aurora off to the north, unlike locations like Churchill, which are underneath the aurora. You see the aurora overhead. We typically see the aurora perhaps on a further more southern location, off to the north. And after we get a good display and it dies down, that's when Steve can appear. And we see this, to the eye, white or colorless band across the sky, maybe a little bit of structure and motion, but the cameras pick up this pink color. And then sometimes little green fingers hanging down from it as well, called a picket fence. And it's got motion from east to west. And it was an odd form of aurora. And it was really identified, and we still don't fully understand what's going on, that it's not particles raining down like a traditional aurora. It's stuff moving, a very hot gas, several thousand degrees, moving from east to west across the earth, again, quite high in the atmosphere, 200 or 300 kilometers up. And that information was really discovered by using photographs taken by amateur photographers to sort of triangulate where Steve was. When Steve gets sighted, people all around Alberta and Western Canada here are seeing it and photographing it from different angles. And so the scientists can use it to figure out exactly where was Steve in our atmosphere. He's up quite high. So it's triggered by aurora displays, but it's not an aurora in the classic sense. It's very hot gas flowing from east to west. But exactly what's going on is ongoing research, and it's very interesting in that amateur astronomers have contributed a great deal to it.
Oh, fascinating. And that actually kind of leads into my next question. I'm wondering about how community scientists and amateur astronomers, how are they, or can they advance our understanding of the aurora? I think Steve's a great example of that, but there might be others out there, other things that have yet to be discovered.
There's all kinds of unusual formations that occur south of the main band of aurora. Other kinds of structures, stable auroral red arcs and things like that, which are related in ways that only people are just beginning to understand. But even though there's professional cameras placed around across Western Canada, for example, and over in Scandinavia, they often miss capturing a lot of these phenomena because they're perhaps quite brief, or the cameras don't have sharp enough lenses and enough definition to really pick up the structure and the details of what's going on. And so it's often up to us as amateur photographers with our, really superb digital cameras and wide-angle lenses and the like, to record this phenomena as best we can, and also to document exactly when the pictures were taken. And so they have a scientific value then, so they can be compared to other people's pictures as well. And so it's really been the photographs taken by amateur photographers and aurora chasers that get posted on Facebook and the like, and then the professional researchers see that and they ask to get our pictures so they can do the research and do the calculations. And I've had a couple of, some of my pictures appear in a couple of scientific papers, and being on the mass, on the banner as a co-author, as a citizen scientist. So it's a classic case of citizen scientists contributing to cutting edge research. It's a wonderful story. There's not too many sciences where amateur photographers in particular can make that kind of scientific contribution, but we do, and the researchers depend upon us to do that.
Digital technology too, as far as like photographs and video. I mean, that technology and accessibility for regular people like myself is just growing exponentially, especially over the last couple of decades or so. So since you don't need to be a professional astronomer to observe and study the night sky, if somebody is interested in photographing the night sky or the aurora, how do you recommend they begin? Do you have like some top recommendations that they should consider as they're thinking about getting into that hobby and study?
Well, of course, to capture the northern lights, you've got to be aware that they're going on, and you have to be, and we have the Facebook groups and whatnot that would send out notices to people. Oh, and people posting pictures right away. Here's what I'm seeing right now. And so if you're sleeping, you're not going to see the northern lights. And so just being aware of when there could be a good display and being ready to get out. When the aurora gets quite bright, you might catch it in the city. You might see it and be able to photograph it and see it from a city limits. But for the most part, you've got to get away from the city lights out into the country. People say, oh, I remember the aurora was much more common when I was growing up as a kid. No, it's no less common now. It's just that the cities are more brightly lit. You just don't see the sky as you did 30 or 40 years ago, for example. So getting out and then even today, people with phone cameras, they can get really good pictures. The latest models of phone cameras, and they do have been made in the last couple of years or so, have these low light modes, and they can capture quite amazing pictures of the northern lights that might even have scientific value as well, because they're labeled as to when exactly they were taken and where they were taken. But for the most part, most of us will use a DSLR camera or one of the newer mirrorless cameras with lenses that you can change, and you put on a very wide, fast wide angle lens, like a 14 millimeter f2.8, very popular lens available in lots of brands. And then you set that all manually, wide open f2.8 or even wider, and a several second exposure. The key thing is focusing. You have to manually focus, perhaps on a bright star or a bright light or something way in the distance, and manually focus so it looks as sharp as possible. The lenses, typically the cameras may not autofocus at night very well, and even setting the lens to infinity and an infinity mark, that still might not be the best point of focus. So you have to learn to manually focus. So manually focusing, and then several second exposure at an ISO of 1600 or 3200, and the lens at f2.8, something like that. That's kind of your formula. But the aurora can change quite a bit, and from minute to minute, and to get quite a bit brighter or fade away, and so you have to quite often be prepared to change your settings on the fly as the aurora suddenly brightens, and then suddenly you need an exposure that's only a fraction of a second, perhaps.
And you mentioned something else about how light pollution can interfere with viewing the aurora, and I want to ask you maybe a bit more specifically about dark night skies and the importance of protecting them in a second. I do want to remind our audience, though, that we're going to have a few minutes available to ask Alan questions. So if you do have questions for him, drop those in the comments right now, and a helpful moderator from Explore.org will send those in my direction. Speaking of, again, that thought that you had about light pollution and how it can impair our ability to observe the night sky. Our cities are growing bigger, our infrastructure is growing. So how does that affect the ability to really see the night sky? And what can be done to protect dark night skies? When you're in a really dark place, viewing the aurora, let's say like at Churchill, for instance, how does that experience differ from like if you were in the middle of a city?
Well, it's a world of difference. It's from city limits now. You can see very little of the night sky in terms of lots of stars. Can't see the Milky Way. I mean, you can see the moon and planets and look at them and enjoy them through a telescope. But things like the Northern Lights, it takes a very bright display to really punch through that artificial sky glow that we have above our cities. And so you can see it when it gets very bright, certainly from a city limits. But for the most part, you've got to get out of the city, and it doesn't take a great deal of distance necessarily. Get away from underneath the immediate light dome of the city. And the big question always is when a good aurora is happening or about to happen and people are getting excited is, where do I go? You know, that's what people are posting on Facebook. Where do I go? And every place, Calgary here and Edmonton and other places will have favorite locations where people go. And on an aurora night, when it's anticipated to be quite good, or it is turning out to be quite good, some of those locations are just jam packed with traffic jams causing real safety issues as everybody's trying to pile into the same place. It's become so popular now, and people are so wanting to see the Northern Lights that, you know, they're willing to do kind of dumb things in terms of driving anywhere off into the city, getting away from the city and getting stuck on country roads and causing accidents. And so it's best to try to have a spot in mind where you can go quite easily and head away from the city and be safe and not parked right on the road and where there's a parking lot or something like that to get your pictures and have a spot in mind. And typically you want to go north of a city because the Northern Lights are going to be to the north, so you want to get away, put the city lights behind you to the south.
And do you think there's, an opportunity for us to sort of enjoy city life, but also at the same time reduce, the amount of waste light that's going up into the atmosphere? It seems like, many of us unfortunately don't have that opportunity to really ever see like a tremendously dark sky. And if you haven't seen that, definitely try to put that on your bucket list because it is amazing to see or a night sky that's unpolluted by light. So what if somebody is at home and they're concerned about light pollution, what could they personally do to maybe help reduce the amount of light that's just kind of escaping up into the atmosphere?
Well, yeah, it begins at home, and all you have to do is just turn off your lights, like the outside lights or whatever. For the most part, they're probably not doing anything to make your place safer and secure. They're just allowing the thieves and the bad guys to see what they're doing. There's no correlation between the amount of light and the amount of safety and security. And so, or if you have outdoor lights, there's all kinds of ones that you can buy that are shielded, where the light just goes where it's needed, out onto the driveway, the steps, whatever, and it's not glaring up into the sky. And so there's all kinds of, there's an organization called the International Dark Sky Organization, Dark Sky Society, and on their website there's all kinds of fixtures that they promote and sort of authorize as being approved dark sky friendly lighting fixtures. And so you can do that at your own home and just make sure they're well shielded. And these days they're all LED lights, and the really bright white ones are not favored. There's a lower temperature, more of a warmer temperature LEDs that are more, again, sky friendly rather than the big bright glaring lights. And you see those on the street lights. That was the first wave of LEDs to go in, bright as possible, and they're just too glaring. And slowly people are beginning to realize that those are ecologically unfriendly. They're damaging to the environment in many other ways than dark sky. Getting rid of dark skies or hurting dark skies, and going to a more lower temperature, warmer color of LED lights. And so you can do that locally, and you can, if there's an opportunity in your local town, neighborhood, whatever, if the local community is refitting lights to lobby for those kinds of lights. They're more common, more commonly available now, and towns can put them in, elect to put those kinds of lights in, the better quality lights, fully shielded and a warmer temperature LED rather than the bright glaring, especially ones with no shielding on them, just glares everywhere. And those are unsafe because they're so blinding and glaring. You now cannot see properly anything that's in the shadows at all.
All right. So yeah, some really great advice there. Definitely check out the International Dark Sky Association if you're interested in learning how to reduce light pollution in your community and at your home. We did have a couple of audience questions come in, Alan, and the first one here is one that I actually have not pondered. So I don't know if you know, but I'm going to ask you anyway because I definitely don't know the answer. And that is, somebody was wondering, does global warming make any difference to the aurora? And I think maybe the premise behind this question is we are changing the chemical composition of the atmosphere by burning fossil fuels. Would that have any potential impacts on how the aurora behaves?
No, none at all. As far as I know, as far as anybody knows, no. The only difference is that it could make places cloudier and cloudier and harder to see the aurora, perhaps, and especially in more northern climates underneath the auroral oval. We typically go there in the middle of winter when it's clearest. It's coldest, but that's when it's clearest, and we have the best chance. The aurora happens year round. The aurora doesn't care how warm or hot it is down here on the Earth. It's occurring way up there. And so the aurora is happening year round, but typically we associate it with a winter sky, winter phenomena, because where it's best seen in the wintertime. The nights are darker, they're longer, and also that's when it's clearer. And so that's why we go to Churchill and take groups up there in February and March, same with Alaska and whatnot. That's the prime aurora season. But the aurora can be happening year round. So no, global warming makes no difference to the aurora. It's all well above that, up in the upper reaches of the atmosphere. And the oxygen and nitrogen in that composition is not changing. We're certainly adding other things like ozone and or other kinds of chemicals in the upper atmosphere. There's another phenomena called noctilucent clouds, which occur in the summertime, or can be visible in the summertime. Very high altitude clouds. They're up around 80 kilometers, sort of the bottom range of where auroras occur. And those clouds are thought to perhaps be related to climate change in terms of man-made pollutants getting up there and forming particles that the clouds can form around. And so they have an association with global warming and human-made changes, but not the northern lights.
And a lot of people, of course, are interested in aurora forecasts and using those to help us enjoy the aurora. And there's some really great websites that help predict the aurora. So hey, what might be a better night to go out versus another night. And somebody was asking a question sort of along those lines, because if you look up those aurora forecasting websites, they'll often give you a KP index or a KP number. So somebody was wondering, what does a KP index mean, and how do they determine the level of the aurora versus low versus high, for example?
Yeah, if you go to websites, the one that I typically refer people to, spaceweather.com. And that's where a lot of people post pictures of the aurora. But it changes every day. And certainly if there's an bright aurora expected in the next day or two, there will be notices there. Plus, there's a readout of the current KP index and what it was in the last 24 hours, and a little picture of where the auroral oval is as well. That's generated by the National Oceanic and Atmospheric Administration, and all the apps and websites about aurora use that same image of the auroral oval. And when that oval gets brighter and wider and turns yellow to red, that's when you're in for a good display. And that's when the KP index goes up. And KP is simply from the German word for number, planetary index. It's from a scale of 0 to 9. And up underneath the auroral oval, like places like Churchill, we get great displays when it's only KP 1 or 2, but we like it to be 3 or 4 or higher. But from further south, where I am, in Western Canada, we need to have a KP of 4 or 5 before it gets kind of more up in the northern sky, and it can come overhead for us at, say, KP6. To see the aurora down into even the northern tier states of the US, you need a KP 6 or 7. And when it gets up to 8 or 9, which is rare, it can be seen down into the southern United States, maybe just as a red glow on the northern horizon. But it can come much farther south. And it's generally, the KP is measuring the disturbance of the Earth's magnetic field with lots of magnetometer instruments scattered all around the world. So it's kind of an average of all those readings. And so you can sometimes get a low KP and yet quite a bit of activity, because locally it's higher, but the average is kind of lower. But that's, for the most part, we want a KP up as high as possible to get us a great display. And so when a site like spaceweather.com shows you that the KP is high, or is saying it's going to be high, that's when you want to, be prepared to get out and get to a spot and have a look for the aurora.
Well, this has been a great conversation. I've certainly learned a lot more about the aurora than I knew before. The aurora is, it's so many different things. It's ephemeral, it's ethereal, it's otherworldly. I like to describe it also as mysterious. And then lastly, as I think you've helped to illuminate tonight, it's becoming more understandable. I'm a fan of Carl Sagan, and I kind of wish that he was still alive to provide us with some wisdom in this century. But he has one of his quotes from one of his Cosmos episodes. He said, "There was a time when the stars once seemed an impenetrable mystery, and today we have begun to understand them." And I think the aurora is kind of the same. It was for a long time such a mystery, but now we're beginning to learn more and more about it and understand it. But there's still so much more to discover. And Alan, thanks for sharing your knowledge of the aurora and helping us to wonder about what else the aurora might teach us in the future.
Thank you, Mike. It's been a pleasure.
And my guest was Alan Dyer, an astronomer, author, and photographer. You can visit his website to see his work at amazingsky.com. Check it out. A lot of great stuff on there. And of course, if you want to watch the Northern Lights on explode.org, you can still do so. It's a great time of the year to do that right now. If you're a night owl on the East Coast, tune in maybe tonight or tomorrow night. If there's not clouds, you might have a really great show. So check that out on explode.org at any time. And my name is Mike Fitz with explode.org. Thanks for watching. And as we like to say here at Explore, never stop learning.